All right, guys, welcome back. So I'm finishing up the rotor, and it turns out you can use these with acrylic. You just have to be smarter than the acrylic. And I needed to put these two in here like this, not like this, because when I push the rotor, when I push the the ring magnet end piece, whatever you call it, when I push it up to lock it in, it goes about this far. I can lock it down, and then from here, I can put in a couple more bolts to keep it really stationary and not, bend up like this. So yeah, it's coming along good. This guy that's one side. I have to do each side by itself. I made some feet to go underneath here, which will work something like that. I was gonna take the wood down and do it, but that's just, yeah, I didn't feel like taking down. I mean, if you see where my wood is, this is where I keep some of my wood. I have a big wood shack out back, but these are the pieces that I keep on hand to do stuff. There's all my hand power tools up on that. See, behind all that nonsense is actually a home built shelf system. It's just, I really got to clean it out. I mean, I really got to straighten it out. Basically, I made everything in here except for, power tools like that. But my disc sander, I even made a belt sander way over there. Let me see if you can see it. Out of rollerblade wheels. This workbench that I'm working on, I made that too. Made this guy. I love making my own tools. It's really weird because what I end up doing is I end up making my own disc sander and then buying one, making my own belt sander, then buying one. It's really weird. I end up making my own tools, loving them, and then it's just crazy. That's a flip table. Never mind all that. Anyway, hopefully I can get a first run today. This is looking good. I'm getting ready to take this plastic off. This paper off. And yeah, we'll see how it goes. Stay tuned. All right, so we're almost there. I've got the two ends sealed up. I've got the feet on there. So now what I need to do now is, since I have some time, I will fill these up with resin for this guy. If you guys remember from the last video, I decided to bag the 8-pole one because of the uncertainty of the non 3D printed parts. I know with these, they're all going to weigh almost exactly the same. They have the same depth. I'm going to put resin in there so I can pop them in there and then do the same thing, screw on the magnets. So I've got some stringing in there, which I never have stringing. I tune my 3D printer pretty well. I almost never have stringing unless I use Prusa slicer. I don't know. I've tried it a million trillion times. I cannot get Prusa slicer to work for my printer. So I stick with what works, Kira. Anyway, stay tuned. So, quick note, it's going to be interesting. So this is the copper infused PLA. I still had some, so I decided to use it. And again, this particular copper infused PLA is not a lot of copper, but it does make for a stronger print. But I'm curious on how the resin's going to react directly with the PLA. I mean, the layers are pretty tight, but resin does have a tendency to heat up. Now, when I did it in the PVC tube, it wasn't a big deal. But I'm curious how it's going to react with this guy. Is it going to seep through the seams or the layers? I don't think so. But if it gets really hot, will it deform it a little bit? After I pour it, I'll wait about an hour and bring you guys back so you can check it out. Stay tuned. All right, so it's only been maybe 10 minutes, but already 96, 99, 100, 105. What's interesting is I poured this one first and this one last. And you would think the first one that I poured would be hotter. But it's like this one's the hottest. All right, we'll let it sit for a little while longer, and then we'll come back and see what happens. Stay tuned. All right, so the new platform came out great. Yeah, thanks, Magnus Attractus, for suggesting laminated wood. Actually, that's not laminated, it's just screwed to it, but it does make it much more sturdy. Yeah, this should work out really well. I'm going to give these guys quite a while to dry, and I'm still going to go back and test the heat on those guys. Excuse me. That was probably really loud. Stupid, sorry. While I'm waiting, I could cut these off, but not too short because I may have to put an extension. No, you know what? I'm just going to leave them alone because I may have to put an extension on here. I may have to bring this back a couple of millimeters, but I don't know. But it should work pretty good. I'm hoping it will. What I need to do is find some smaller bolts for these two set nuts, whatever they're called, inserts. Yeah, I'm going to have to find some shorter, small head bolts. I was going to use these, but they're too long. I could cut them, or I could just go to Ace Hardware and get me some short ones. Any excuse to go to Ace. Stay tuned. I don't even know if any of that recorded. God, I hate this stupid camera. I got to get a regular recording. So, PLA. So this is in Fahrenheit. That's 128 degrees. But if I switch this, that's 52 degrees. PLA gets soft at like 170, 180, 190. But the more interesting thing is, so I'm not too worried about this heating up much more than 120 degrees Fahrenheit. But the thing is, this is getting a huge dip in there, meaning now resin always does that. You pour it, it heats up, it starts to harden, and you lose some volume, but not that much. That's a lot of volume gone right there. It was crowning when I got done pouring it. So, yeah, that's interesting. It's funny because this one is still okay. It's not going to be a big deal, even if it drops down another couple of millimeters. It's not going to be that big of a deal. I will have to probably, I don't know if I'll have to weigh these and then add or subtract. It's probably a good idea to do that. But I don't know how much of that lasts. God, I hate this freaking camera setup. Actually, it's my phone. But it's interesting. It is getting hotter. .32. Let me put it back on Fahrenheit. Oops, 120, and the side of it, 102, 110, 103. Yeah, that's interesting. All right, stay tuned. All right, guys, so I've got everything all ready. The base looks gorgeous. This guy looks like it's going to be perfect as far as the fit. And then I ran into an issue. This newly 3D printed piece might give you a hint. These magnets I'm using, the end magnets for the rotor, are much more powerful than the ones I were using, and they're the same thickness as these two magnets. When I went to put it in there, it literally shot these magnets out because I'm pushing it in there and it's pushing against the back. The poles are pushing against the back there to lock it against the back plate here. So I had to rig up some kind of piece. This is just a test piece. It'll go on there. I'll of course take the screws out. This will sit flush up against there. It'll sit flush up against there, holding the magnets in. The screws will go through like that. I'm printing out 2 of them. They're going to take a little while, but that's going to work great. And again, this is just a test piece, and I actually got it pretty good on the first shot. I made a couple of adjustments. I'm not going to use this copper infused PLA. Whoops. Yeah, I'm not going to use this copper infused PLA. I'm going to just use regular, I think, red PLA. But yeah, I'll take these out, pop this guy on there, pop some holes in there so I can put the screws through, and that'll hold the magnet in there. This, like I said, this was just a prototype. In the actual one, this lip is much bigger, so it's going to come to at least like down to here. So it's going to hold the magnet in really good. Yeah, because I can't have that, what happened before. It shot out, shot across here, it hit up against here. Thank God it didn't damage anything. But yeah, so unfortunately, we're not going to get a first run today. But very soon, guys, very soon. Ciao.